All right, so our next problem here, these next two have to do with irregular shapes. Okay, so it says find the perimeter of the figure below composed of a rectangle and two semicircles, round to the nearest tenths place. All right, so let's talk about this figure. Let's look at the rectangle first, right? So even before that, let's go ahead and highlight the outside of this figure because that's what perimeter means, right? It's the outside. So there's this length here, then there's this semicircle here, then there's this length here, and then this semicircle there. So this perimeter is made up of two of these long lengths and then these two semicircles. Well, let's talk about this, right? The middle piece is a rectangle with this semicircle cut out. If this top side is 15, so is this bottom side. So there's two of your pieces of the perimeter. And then these two semicircles are the same. Each of them is half of the circle's circumference. But if there's two of them, then it's just the whole circumference of the circle. So that's all this is. This perimeter is 2/15 and the circumference of this circle. Now this 10 here, I believe is the diameter because it goes all the way across. So I want the radius. The radius is half of that. So the radius is half of the diameter, which is 5. So now to find the circumference of that circle, it's 2 pi r. That's 2 pi times 5. That's 10 pi. Now I will round this in the end. So what is our total perimeter of this figure? Well, it's 2/15. So you could do 2 times 15 or 15 times 15. I don't care how you want to do it. 2/15. And this 10 pi, which again is the combined two semicircles to make the full circle. So I'm going to type this into Desmos graphing calculator. So let me get my calculator, not geometry calculator. So I said it's 2/15, 2/15 plus 10. And I can use, let me, hold on a second, Alt T, the keyboard has the pi button right there. You can also type in the letters PI and it'll do it as well. And there I go. So that is 61.41. Now it says round to the nearest tenths, I believe. Let's double check that. Round to the nearest tenths place. Yes. So right now, let's do some quick rounding rules. So right now, the 4 is in the tenths place. So it is the 1 I'm looking at. That 1 is 4 or below. A 4 or below does not change that answer. So the answer is 61.4. If this 1 were a 5 or above, it would round the 4 up to a 5. That's your rounding rules. Please remember that. Don't get problems marked wrong because you can't round correctly. So I'm looking at 61.4, I hope. And there are no units, so that would just be in units. Your fingers, let me double check again. Yep. Oh yeah, and there we go. All right, last problem coming. Okay, so if you look at this shape, very similar shape, right? It says now find the area of the shape below, right? Find the area. Again, it's a rectangle and one circle, semicircle added on and one removed. And it says round in the nearest tenths place. So now this is kind of trickier because now we're looking for the area, which is the inside space. So the two shapes are this shape right here, which is part of a rectangle hollowed out by this semicircle. And then, of course, this semicircle, right? Okay, so again, let's talk about a couple things. So in this rectangle, if this top side's 14, this bottom side is 14, all right? And then we have 12 and 12 over here, right? So to find the area of what's left over from the rectangle, I'm going to take the area of the rectangle and I'm going to subtract half the area of the circle. Put a C for circle, right? Okay, so the area of a rectangle is base times height. Let's call the base 14 and the height 12. Okay, that's going to be minus half. Area of a circle is pi r squared. So this 12 is the diameter. So the radius is half of that, so that's 6. So this would be minus 1/2 pi times 6 squared. So whatever this comes out to be, that's this blue shaded region. Okay, so I'm going to leave that alone for a second. We'll type that into Desmos later. Now, what about the red area? Well, the red area is just the area of the semicircle. We did that right here. Half the area of the circle, half pi r squared, half pi times 6 squared, half pi times 6 squared. So now notice, you are subtracting a semicircle here, but you're adding a semicircle here. What's really going to happen? Watch this. 14 times 12 minus 1 half pi times 6 squared plus 1 half pi times 6 squared. These two things will come out to be the same and they're going to cancel. And the answer is simply 14 times 12. Okay, so maybe I shouldn't have added this one because it turns out to be a little simpler, but it is what it is. So 14 times 12. So in Desmos, I will simply do 14 times 12. And that is 168. And that would be units squared. Fingers? Oh yeah, there we go. Okay, good. So that is the delta math. Now let's move on to edge elastic, which is going to be our coordinate plane stuff.